Hello, everybody. We're going to be starting soon, so please sit down and shut up and stuff like that. And I'm wearing the big scary hat, so, you know, I'm big and scary and authoritative, you know.
That's what a chair hat. That's what a chair hat should look like.
Henrik,
really.
you were not supposed to laugh at that.
Warren, that's what a chair hat should look like, really.
Yeah, but Warren,
admit it, you respect me more now.
Possibly looks scary.
More than you believe.
I like the Viking hats, though. They were good.
Okay, so we'll give people another minute or two to file in and sit down. Okay, so for those of you who are really paying attention, you'll see that this says that we're in Hawaii. It turns out, unfortunately, that was just optimistic thinking. We are not, in fact, in Hawaii. But Prague is really good, too.
Or actually, we are in a better place.
Yes. So.
Okay, can somebody close the door? There is quite a bit of noise coming in from there.
Thank you. So this is the IETF note well. Please note it well. Hopefully you have already read it and understood it. I'm not going to try and summarize it. If you don't understand any of it, please go talk to your lawyer and legal counsel and similar stuff. It says important things.
And if you don't understand it right now, it is a good idea to try to understand it outside this room if you plan on speaking.
Oh dear, the battery has almost run out on my clicker thing. So welcome to Dane. Dan York said that he will be the JavaScribe. Somebody said they would do minutes. Thank you. David will be doing minutes. Somebody stole this. Does anybody have the blue sheet clipboards? Okay then, them 6 low-pad people's taken out things. Well, we can just hand around the blue sheets without that. Wrinkly blue sheets. Oh well. Please fill them in. The secretariat shout at me if we don't. This is going to be our agenda. Oh yes, for the mic lines, we will always let the JavaScribe get priority because it's hard enough to work remotely. So if there is remote people with Jabber comments, the JavaScribe jumps to the front of the line. Also, we are going to be asking for people to commit to review to things. If you put your hand up and commit to review to something, we're going to point at you because we can't always see. Shout your name out loudly and we will repeat it for, the scribe, etc. We also don't want to end up in a situation where, scribe or minutes taker doesn't know people's names, and so we end up forgetting who's going to do reviews. This is our agenda. Does anybody have any agenda bashing? Are you expecting to speak and do not see yourself there? Or more importantly, are you there and we're not expecting to speak? Okay, in that case, moving on, we have, surprisingly enough, Schumann.
Hey,
I skipped 2 slides.
Yes.
And now I've lost mouse. There's my mouse. Wow. Status.
Okay, so we have basically, this is a current status. We have 2 documents that are sitting in the RFC editor's queue. We have 2 documents, sorry, one is missing from this slide, sorry. There is OpenPGP that is in a AD evaluation, and there is the SMTP operations, or the Dane operations that is in IETF last call. both the green documents are waiting on the operations document. So once that goes through, these three will all pop out at the same time. We want to finish this as soon as possible. So we want to get the ESMA based on feedback we have got in the last few days and based on the number of reviews we have got. Thank you to everyone who has sent in reviews to the ESMA document. We are going to try to finish it before the next IETF meeting and have it out of our hands. So we are going to be able to start on the mailing list discussing the important questions. Do we adopt more documents or do we shut down? And if there is time at the end, we may discuss it there. We're fine. More reviews of SMIME are always welcome. Thank you. Next, Schumann. Yep.
Okay, so this presentation is about the following draft. So this is, let's see, draft Shore TLS DNSSEC chain extension -01. This is a new draft, although we managed to squeeze in one revision before the IETF 93 cutoff. So if you haven't read it yet, make sure you read the current version. And it is a proposal to define a new TLS extension by which a TLS server, if signaled by the client, is able to deliver a DANE record corresponding to its server certificate, along with the full chain of DNSSEC records needed to authenticate that record, going all the way back to a configured and agreed upon trust anchor, which will normally be the root of the DNS. And the client then obtains this DNS chain in one go, authenticates the chain, and then uses the DANE record to perform DANE authentication of the server. One thing I should mention is that the crux of this idea is not actually new. So you may remember a few years ago, Adam Langley did something called, DNSSEC stapled certificates, where he did the same thing. He embedded a chain of DNSSEC records in an X509 certificate in a custom extension. So this is a kind of reimagining of the same idea, although the implementation is substantially different. We're proposing to do the same thing, solving the same set of problems, but using in the form of a TLS extension, which we think is a more dynamic and maintainable way to do the same thing. All right, so this is the format of the data that is returned in the extension. So for people, non-TLS people, this is written in the TLS presentation language syntax, which you can look up if you read the TLS RFC. But basically what it is a sequence of RR set structures. Oops. I did hit the pointer. Work. Okay, RR set structures. And each of those structures contains a DNS RR set together with an accompanying RR sig, a DNSSEC signature over that RR set. And the records are ordered starting from the target record, the DANE TLSA record typically, going all the way up to the configured trust anchor zone, normally the root zone. All right, so here's an example to illustrate. So the hypothetical DANE-enabled HTTPS server at www.example.com, if it were to deliver this chain, it would look like the following sequence of DNS RR sets. The DANE record first, and then example.com's DNS key and DS RR sets, followed by the same for COM, and then lastly, the root of the DNS. And each of these is accompanied by an RRC. Okay, so what is the rationale for this delivery mechanism for DNS records? So a number of things. So if we deliver these records in one go to the client then no longer has to perform all these additional DNS lookups in order to get the DANE record and the signatures. So it avoids the associated latency penalties associated with doing all those lookups. The other important thing is if the TLS client is behind a middle box that prevents it from being able to successfully issue DNSSEC-enabled queries or DANE queries, then this solves that problem too. And lastly, the TLS client can then independently authenticate the DNSSEC signed record without needing access to a provisioned validating resolver to which it has a secure connection. So I forgot to put it on the slide, but the last point means addresses actually the DNSSEC last mile security problem, where you may have a stub resolver with an unprotected path to a validating resolver. Okay, I see a question, so I'm going to let you interrupt me. Go ahead.
Your last point is wrong.
Okay.
DNSSEC protects the last hop anyway. It doesn't need a secure connection if you're doing DNSSEC.
Right.
That's the whole point of doing DNS, having
exactly,
the repository being returned.
Yeah, what I'm saying, the stubs typically today don't do DNSSEC.
The stubs don't do it, but you get the answers back, and you look in the answers coming back and do the validation yourself in the application layer. Mm-hmm. So all you got to do is send the DO bit out. So if you're doing DNSSEC in the application or in a library, the application is calling.
Right.
There is no trust problem.
Right. Okay. So if this, let me ask you a question. If the stub can send the DO bit out, but it also has to validate the DNS signatures that come back. If it's not doing that, then you still have a security problem.
Right. I think the salient point here is the first one, that a lot of clients can't get the DNSSEC stuff to start with.
Right. Okay. Yeah. All right. So we'll come back to it. Let me finish my presentation first. Yeah. All right. Okay. So there may be other possible use cases. So the one that I thought of, which isn't in the draft right now, is the case of link layer authentication. If you're doing 802.1x and EAP, and you're using an EAP method that employs TLS, then in that case, the client has no ability to issue any DNS queries at all. In fact, no queries other than the encapsulated security protocol that is allowed in EAP. So this would possibly address that use case too. So what's happening on the server side? Well, the TLS server has to build the DNSSEC authentication chain and maintain it. It returns the chain in the DNSSEC chain extension if the client asks for it. And then it caches and reuses the chain across multiple TLS connections. But it has to maintain the freshness of the chain by periodically rebuilding the chain as TTLs and signature validity periods of component records in the chain dictate. On the client side, we, as currently written, the client sends a DNSSEC chain extension with empty, with no data. It obtains the chain from the server, authenticates it with its locally configured trust anchor, and then uses the DANE record to perform DANE authentication of the server certificate. The other thing that it has to do is perform trust anchor maintenance in case the trust anchor rollover happens. So there are a number of possibilities for doing that. There's, of course, RC 5011, which we talked about at DNSL quite a bit. It could do it itself, or it could obtain this service from an external process, like an operating system provided service. We need to think about this problem a little bit, because if the client is actually stuck behind a middle box that does not allow it to issue queries for signed DNS key RR sets, it may not be able to successfully perform 5011. So maybe one of the other things that were discussed, like Joe Avley's alternate trust anchor publication mechanism, that might be a solution for this. Okay, so some future work. We need to deal properly with C names and D names. Right now, the chain is defined to be essentially a linear sequence of DNS records, but if you have C names and D names, you may have to traverse additional branches of the DNS tree. So we need to refine or enhance the chain structure to accommodate that. The other potentially tricky case is that of wildcards. I'm not actually sure if it will be common to see TLSA records that are synthesized from wildcards. But if they are wildcards, the DNSSEC proof for wildcards is a little bit trickier, because you need not only the signature over the wildcard name, but you also need an NSEC proof that denies the existence of the explicit record. So that's another thing that our chain doesn't accommodate yet, but we're thinking about it for the future. And under consideration, for a future revision, the client could cache DNS records that it's previously seen and then offer those up in the extension that it sends to the server. And then the server could potentially deliver a shorter chain with those records omitted if we're concerned about the size of the chain and we need to do size optimizations, of course, at the expense of additional implementation complexity and work on both the client and server's end. So I have a few more slides, so let me do that before I take questions. So one of the things we're trying to do is we're trying to develop some prototype code to help us validate our protocol design. And there's a browser implementation in the pipeline. We should be able to talk about that soon. But I attended the IETF hackathon on Sunday. So just to prove that I did a little bit of work, I hacked up a little TLS server that sends out this extension, consumes this extension, and sends back a chain. This is for one of the servers that I operate, and I just wanted to give you a sense of the size of the data in the chain. This is about 3,000 bytes, so I don't know if that's big or scary or if it's okay. I mean, I've certainly seen certificate chains longer than that. But in case we have to do any optimizations, we should consider whether it's worth doing it or not. I think that's all I had. More details are in the draft, and I'll take questions.
Before questions, I have one question for you.
Yes.
Is this here for informational, or do you?
Yes, very good question. So the idea was to take it to the TLS working group because it is a TLS extension. However, it has a lot of DNS protocol stuff in it, so we feel it needs to be reviewed by Dane. Okay, so.
Daniel Kahn-Gilmore.
Yeah.
I just wanted to add to your list of potentially problematic areas, SRV records.
Yes.
And I mentioned this on lists. You've got CNAME and DNAME as things and wildcard to think about.
Right.
But SRV offers additional challenges, particularly because we don't know, with an SRV lookup, if you're trying to validate the remote peer, you're often validating multiple pieces of the DNS chain.
Right.
So, like you're trying to validate imap.tcp.example, and that resolves to mail. Something else.
True. Yeah.
And you don't even have the hint of SNI or anything like that to decide which chain to offer.
Yeah, we should certainly think about that. So the initial use case for this is Dane authentication, where we're not actually looking at SRV records. But go ahead.
Sorry, my impression was that if you wanted to use Dane in an SRV context, the advantage of Dane was that you could just verify the entire chain, including from the right. You're looking for IMAP services for your example.com mail account. Right. Well, Dane can, if Dane doesn't plug the SRV hole, then it doesn't solve the problem.
Okay, yeah, fair enough. All right. So if if the Dane record is on the target of the SRV record, you want to include the SRV in the chain too, right? Okay, good point.
Christian Grothoff.
Yes.
This reminds me a bit of a related issue with DNS over TLS, where it seems to me that you're starting to really turn the stack upside down. When I looked at it at the beginning, TLS was usually above DNS.
Right.
And now these days it's more DNS is also above TLS.
Yes.
And then we end up with software architectures where GNU TLS links against the DNS library libunbound, which links against the TLS library libNSS or OpenSSL. I'm not sure, maybe in your browsers you always just fuse all of those stacks into one gigantic mess. But if I think about layered architecture, I think we really need to decide which way around we want to have those things. And I personally would favor an approach where we keep DNS below TLS and just say we send the Dane record as an auxiliary additional record with the DNS request, so we don't have to do the second request, which is a problem.
Sure.
But I wouldn't really put this into the TLS handshake. I think this is the wrong approach because it makes this problem of how do we stack the layers properly just worse, and our software that we will build when we build concrete systems will be really awful in the architecture afterwards.
Yeah, right. So I agree there's certainly additional complexity, which is, my personal inclination is I agree with you, but that doesn't solve the use cases for all possible applications. There are some applications the 3 points that I mentioned, if they can't address them, they will be unwilling to do DNSSEC and Dane. So we're leaving out entire application communities if we don't try to at least offer a solution to their problems.
Dan, you're channeling Victor. And I should say to folks, we do have a number of people who are remote, so please do keep saying your names. Thank you. But Victor asks, should RR sets providing non-delegation of intermediate nodes between the RR set and signing zone apex be included?
Okay, so let me make sure I understand that question. Could you repeat it one more time?
Should RR sets providing non-delegation of intermediate nodes? Oh, sorry. Proving. Should RR sets proving non-delegation of intermediate nodes between the RR set and signing zone apex be included? My apologies, Victor.
Okay, so proving non-secure delegations, you mean? So I think if that's the case, then you won't end up at the end of the chain with a usable DNSSEC signed TLSA record. So in that case, I would say the server decides it cannot build a chain because the client can't use it to authenticate the server anyway with DNSSEC. So I would exclude that. Go ahead, Pete.
Paul August.
Yeah.
So as I told you briefly as well before, I would really like to see the DNS format being used, because if you're shipping a binary blob, you might as well just do a DNS blob, because that gives you interoperability with tools, libraries, and a lot of other things. Makes debugging easier. With my draft author hat up on the DNS, the query chain draft, it would be really nice, because that draft will cause the code to be written for this, so you don't have to write your own server tools to generate all these chains. It would also do the right thing with adding the right records to it. So I know you're pushed between two worlds, so just consider this a push.
Right. Okay. Yeah. Good point. So on the second point, so the eDNS chain query thing. So I agree that would make implementation of building the chain much easier. So once that's available, I mean, I haven't actually seen any implementations of it yet. I think I would propose that server implementers use that to get it. There are actually existing DNS libraries today that already can build that chain for you. And I'll give you one example of a project that I'm involved in, the Get DNS library, which can do that, right, Willem? So the initial implementation that I did just used a function from the Get DNS library to build a chain and return it. So obviously it's doing additional individual queries, whether the chain query can get it in one go from an upstream resolver, right? Yeah, so that would be an optimization we could get out of that mechanism when it's available. On your first point, okay, so let me go back here. I actually agree. So me being more a DNS person, I would have liked to see the structure be entirely DNS wire format. Then I could generate the entire structure straight out of a DNS library and pump on the client side, pump it into a DNS library. But we're working with some application communities who want to do, want to see a little bit structure so that they can know what's in the chain and parse it, right? So we're continuing to have a discussion about that, right? So this is an early draft, so happy to get your input and happy to hear input from other people about that. Right. Okay, sounds good. How many more questions do you have? Go ahead.
Hi, Petr Špaček. I have a question about the application communities.
Yeah, right.
Did you thought, TLS library developers about that and how they reacted? I'm curious about, how their face looked like.
Right. So I don't think we've talked to any TLS library developers. We have talked to applications. So there's one coming up next. Let Richard talk about it.
My name is Richard Barnes, and I'm a lazy application developer. Work for Mozilla. And I've helped work on this. I think some of the things that people are seeing in this are as a result of trying to make this as easy for the client side as possible. A lot of the reason this stuff is desirable is that you have applications out there that might be using TLS and might still be using get-adder info and not doing any fancy DNS stuff. They might not have a DNS library. So, and really, for Dane purposes, the only thing they care about is that there's some way to chain back from that TLSA record to the root, whatever trust anchor they have in the DNS-sec sense. And so I think it's to the degree that as much of the DNS gunk can be simplified out of this, I think that will make it easier for application developers that don't have a DNS library on hand to consume that.
Yeah.
I think there is an opportunity here to try and figure out what the simplest possible DNS set configuration to get to a TLSA record is, to try and promote simple deployments. I came to this by analogy with the certificate format in TLS, which requires, somewhat aspirationally I grant, but it requires that the certificates be presented in validation order. So the server cert first, then the cert that issued that, then the cert that issued that. So that if you're writing a client of this, you can just blow through, straight through, validate straight through, and if the last thing's a trust anchor, Bob's your uncle, you're done. Like I said, it's somewhat aspirational. It doesn't really work that way in reality. But if we could have something that works like that here, wouldn't that be great?
Okay. And we're cutting off the mic lines.
DKG again. I just wanted to push back on the software architecture comment. I actually think that we have better software architectures available that can handle libraries that are interdependent in that way. And I don't think we should let that block from doing this. TLS and DNS are inextricably intertwined at this point, because of authentication.
Yes,
and
true.
we just have to accept that as as sort of the cost of doing business.
Okay, thanks. Yep.
Peter Koch. So 2 hours ago in the DNS op meeting, we learned about efforts to do a KSK rollover. We have a new user for trust anchors here, for the root trust anchor.
Yes.
Have you considered making the design team aware of potential new customers for 5011 or whatever they come up with?
I have not, but it's a very good idea. I will do that.
That was not really my intent, but thank you.
Okay.
Wes Herdick, actually, similarly, I actually questioned why you needed to send the root's DNS key, with it in the first place. We won't go there because my other real comment I was following on him. Warren, our esteemed co-chair, is actually a co-author on a draft to do this over DNS to actually keep the layers clean, like some people want, where we can return multiple records. And one of the things that we are doing there, I should disclose I'm a co-author too, is that we are also appending records like images.example.com when you really went to www. And at some point, I'm sure that this will come up in your space as well, as how many records can we cram in there with all the other R6 as well, which actually requires DNS in the application itself. It's not, you're not just validating the chain from the DNS-sec point of view. You're suddenly populating a lot of other stuff.
Yep. Right. So on your point about whether or not it's necessary to include the root DNS key in the chain, we went back and forth on that question. And the reason it's in there right now is for the purposes of doing trust anchor rollover, it needs to be able to see the DNS key RO set and its flags if the client is doing that. Yes. Right. Okay. So.
Quick check on blue sheets. Has everybody seen them? Okay.
So are the chairs going to talk about which working group? I mean, we said a little bit it's going to be in TLS, but it sounds like almost all the questions were very DNS-y.
We will discuss that, yeah.
Yeah, I think it is between, we need to have the TLS working group look at this and see what directions the two working groups want to take on it.
Yeah, so the TLS, I think, Richard, we have 5 minutes. Where did Richard go? We have 5 minutes on the TLS working group agenda, right, to discuss this, so we will be asking it there.
And can those people who have not seen the blue sheet put their hands up so we know which, so that area and that area needs it. Thank you.
All right, so this second presentation is about client certificates in Dane TLSA records, and here's a draft if you haven't seen it. So what we're proposing to do is reuse the TLSA record, but modify the owner name of the record a little bit to make it more appropriate for client systems where you don't need the port number, you probably don't need to distinguish transports, TLS versus DTLS, etc. So the simplified format that we're proposing is just the domain name of the client prepended with one underscored label, which contains the application service. And the rationale for encoding the application service in the owner name is that you might have a situation where you have the same client device that wants to maintain distinct credentials for distinct applications, and this allows that to happen. So here's a more specific example of a client system device1.example.com, and it's an SMTP client. And the R data of the TLSA record is nothing has changed. This is exactly the same as specified in RFC 6698. And so the authentication model for client certificates is that the client has an identity in the form of a domain name. And this identity does not necessarily have any relation to its network address, because clients don't often have fixed addresses even. The client has a public and private key pair and a certificate binding the domain name to the public key, and there is a signed TLSA record in the DNS corresponding to the domain name and certificate. So we propose two options for specifying the client identity inside the X509 certificate. And the obvious one is the subject alternative names DNS name type, but we are also proposing SRV name, which is an application-specific reference identifier, and that may be important if the client wants to maintain isolation of application credentials from each other and have that isolation in certificates as well. All right, so the other thing that we think is probably going to be needed to make this scheme work really well is a client signaling mechanism. And so the server, for example, may want an explicit indication from the client that the client has a certificate and it also has a corresponding TLSA record, so as to avoid doing unnecessary DNS queries in band with the TLS handshake. The other important use case is if you are doing TLS with raw public key authentication, then the client needs to be able to convey its domain name identity in some manner to the server. And lastly, I wasn't aware of this, but I think Victor informed me that there is actually, apparently there's a lot of deployed client software today that reacts very badly to an unexpected client certificate request, and we need to be able to accommodate these. So, one way of doing this is to have an application-specific mechanism to signal Dane client identity to the server. It could be like a new SMTP command or an XMTP command. But the most general way to do it, of course, is to devise yet another new TLS extension. So that's what we're proposing to do. Hasn't come out yet, but we'll see what the TLS working group thinks about that one. So the client requirements here. Let me clarify here. There's a typo actually in the slide. What I meant was a new TLS extension to convey Dane client identity. So we're conveying two things: not only the domain name of the client, but also the fact that it actually has a TLSA record associated with it. That's what I meant to say here, in case that wasn't clear. Okay, so the client requirements, they have to have a signed TLSA record published corresponding to their domain name and certificate. Client's name must appear in the certificate in one of the identity fields that I mentioned. And in the future, if we manage to develop this TLS extension, it would signal this in the client hello message in the TLS handshake. The server requirements are that the server sends a certificate request message in the TLS handshake. It extracts the client's identity from the certificate that is presented to it by the client, and then it constructs the corresponding TLSA query name, issues the query, authenticates the TLSA record, and then matches the data field of the TLSA record to the certificate. And if all of that succeeds, the client has been authenticated. So I think that's all I had. More details are in this draft, and I would be happy to take questions.
Yes. Hello, Clement Schumper. Wouldn't it make sense to do the same that you did in your previous draft, where you include the chain in the TLS handshake also for the client? So a client could prepare its own chain of RS6 signed records and send that with its credentials. Since you already have that TLS extension.
It would certainly be possible to do that. What I would say is, so you're saying the client builds a chain and sends it to the server, right? So I think it would solve more problems if the server did that, because the client has to verify the server as well, because the client is more likely.
This is about identifying the client.
This is about identifying the client.
And you already have the option in your previous draft to say, okay, I send the option. Usually I send it empty if I just want to see what the server is going to look like. But I could also fill it with my own chain. That wouldn't hurt if there's client authentication required.
Right. That would work. I mean, the question is whether the server actually needs to do that or whether it can just do a few DNS queries to do it, right? So DNS servers generally don't have the same set of constraints that the client has, where they're stuck behind middle boxes that makes it difficult to perform certain types of DNS queries. But yeah, I mean, it would be possible, I suppose. Yeah.
I'm thinking about MTAs talking to each other, for instance. So we have servers which actually act as a client when connecting to another server.
Servers that act as a client.
SMTP servers.
Yes, right. Yeah. I should mention for the SMTP authentication case, you might be able to do it from the client end, but not for the server end, because the server, the way DANE in SMTP works is that the client uses the presence of a TLSA record for the server to know whether to enforce TLS authentication to prevent downgrade attacks. So you don't want to be doing it in the other direction, but it may be possible in the first one. Go ahead.
It's Dan York channeling Victor. And Victor says servers are usually better able to make DNS queries than clients are. It's the same last mile problem.
Yeah, right. So that's what I just said earlier, right? Okay.
DKG, yeah. So I think I brought this up to you in person, but just so that other folks are aware, there's potentially a privacy concern with stuffing the client's identifier in the client hello for TLS. So at the moment, TLS through version 1.2, all of the handshake messages are in the clear.
Yeah.
But in particular, the client hello can't even really. We're gonna hopefully protect more of the handshake messages in TLS 1.3.
Yeah.
But the client can't really protect. There's parts of the client hello that we can't protect. So I want to make sure that we're thinking about this from a privacy perspective and making sure that we're not inadvertently, unnecessarily leaking the metadata about who the client is.
Right. Yeah, so I agree. So in the pre TLS client identity thing that I proposed in this draft, the client would present the certificate only if the server sent a certificate request, right? But right now, it could be the case that if we develop this extension, the client is always automatically exposing the client identity in the extension. So, I mean, one way of possibly dealing with that problem is the client has some privacy and security configuration rules that cause it not to use that extension unless it has to with a certain set of servers that it plans to do this form of authentication with. But yeah, I mean, I guess TLS 1.3 is working on encrypting more and more of the handshake, right? So I don't know if that will address the problem or not. Okay, thank you.
This concludes the pre-TLSA meeting. Okay. Some of you may have noticed a devious plan by people like the document editors of the SM9 document and the chairs to start a discussion. the devious plan succeeded. We got people to react. We got reviews of a document. So I will add this trick to my bag of tricks. So, open PGP document. Okay. One slide. Okay. Yes. So, as I specify, is basically ready to exit or go into the RFC editor's queue soon, hopefully. And it and the S-MIME document propose different locations to store the names. This is maybe okay, this may be not. But we are in the protocols, we are actually have 3 different dimensions where we can add information about how the keys are used or what kind of keys they are. And, well, that's okay. Maybe, maybe not. So the question is, can we reduce these knobs? Open floor.
Paul Hoffman, just a point of order. It's not ready to go to the RFC editor at all. It has not
going to RFC IETF last call.
IETF last call. That's completely different.
Sorry. I assumed automatic acceptance.
So funny enough, some people were suggesting this in the early times when we did some of these drafts. And he said, why don't you use the cert record type and you can do subtyping? It's going to be awesome. And then the author of the cert RR type told me, no, you should not do this. Subtyping was a mistake. And now that same author is a working group chair for Dane and asking if we should do subtyping again.
No, I'm not saying that. It's saying if we use RR types to identify different kinds of search, do we need the name labels?
Okay, so what it basically comes down to is if you have a client that can do both S-MIME and OpenPGP key, it could save one query.
Per guess.
Yes, but at the expense of all the clients that only implement one of them to have to filter through the garbage.
Okay.
Dan York speaking as me, not JavaScribe. The one challenge I've had with all of this is that we're already seeing an issue getting these records deployed out there in the real world of DNS operators and others who have web provisioning interfaces that only allow people to enter in at certain amount records in certain forms. And so right now we have an issue where a lot of people can't put out TLSA records because their DNS provider or whatever software they're using requires them to use some kind of GUI form. They can't do raw zone entry, and they have to go and do this, and they have to pick from whatever the DNS operator is. Yeah, as Warren is making signs of shooting himself up there. So I guess my question is, right now we're sort of in a stage where we're out there trying to go and get these DNS operators to put TLSA in there, so that we can at least get TLSA records in. And now my concern with all of this is that now after we do that, we've got to go back and try to get them to add S-MIME A, and we've got to get them to add OpenPGP, and go and get them to add whatever's the next thing we decide we want to be Dane-like that doesn't use TLSA. So I guess my concern is just, as Paul's looking, my point is, I worry about having too many different record types when the provisioning interfaces and the way that people are doing this right now, are not that great, and have to be manually changed to incorporate new records. So the question really is, how do we get this deployed?
Peter Koch, DNIC. So my worldview of the DNSSEC is a bit tiny, so I have like 40K domains to watch. The vast majority of those domains, DNSSEC signed, is currently completely run by registrars behind the scenes, which is in response to Dan York's comment that somebody is manually entering domain names and record types somewhere. The majority of deployment we see is behind the scenes. I appreciate the observation that there's a bunch of interfaces that offer manual intervention, but this is probably not the future. At least for us, it's not the present. So can we please have an assessment of the, say, the volume or the numbers that we're talking about? We do have in DNSSEC and also in DANE, we do have kind of a history of solving geek problems, right? Geek being the early adopter or even before that. So let's not solve the early adopter problems. Let's go to scale. And that also means, and I'm sorry to say that, a bit of patience. What we also see is there's an increase in DNSSEC deployment, but actually adding TLSA records takes time because people need to develop processes, and you can't just go there and give them the TLSA and enter this manually. People actually care about doing key rollovers for their certificates, and that takes time again. So the response to lack of deployment or to slow deployment is not necessarily more protocol, because that sends an interesting message out to the masses. Somebody else had the proposal that we take the August off, maybe add September. So throttling the development work or throttling protocol development might actually be beneficial to deployments, even though that might sound paradox.
Dan York responding to Peter on that. Peter, I totally want automation. I mean, I don't want to have any of these manual interfaces around. I'm just saying right now, certainly when we're in these earlier days of DANE deployment, as we're trying to get people out there using it, what I'm seeing is a whole lot of different web provisioning interfaces that people have to use. As I've had a number of people come to me and say, I want to get DANE deployed for my domain. What do I have to do? And I've told them what they do, and they go and try to do it, and they can't. Granted, you're right, it's early adopter stage, but still, that's what we're looking at the moment while we try to build the base of people using it.
Paul Hoffman. So I really think that whatever we do is going to get deployed at about the same rate. That is, if it's a little bit harder for people to do by hand, people will work harder on tools. If it's very good for tools, people will figure out how to do things by hand. Similarly, for the consumers of these, we had originally said, OpenPGP should be separate from SMON for these reasons, and now we're thinking, maybe they should be combined. And you know what? It's just software, and people who are motivated to make this work are going to make it work. We might make a dumb decision that could delay a developer by 3 months or 6 months. That doesn't matter. Arguing about this and saying, I predict this with no data is going to take longer.
Thank you. Mark? Okay.
Dan York, by the way, I think Peter's got a great idea that we should do some, gather some data about the, what, no, Paul?
Oh, Paul. No.
Bad data that we can't measure is worse than no data.
All right, I agree with you on that.
This is probably not a problem for DANE working group, because it's generally a problem with any new RR type. So, well, maybe DNS ops should develop, some description of DNS records, so you can just download, XML file to your crappy GUI and get all the new records, something. But I don't think the DANE group is the right place to solve it.
Mark Andrews. We already have a protocol which allows any client to add any record to any name server. It's called update. It is 15 years old, 16 years old now. We can authenticate that. The hard part is getting these registrars to actually do it and implement it. Name servers don't need to know the structure of these records. They are peak blobs as far as name servers are concerned. They have been for a decade now.
I'm not opposing that. It's about the user interface, and that's the problem. You can do, I think that even Windows Server 2003 or something Asian can actually add arbitrary record if you use NS update. So it's actually about the user interface. Sorry.
So yeah, oh, sorry.
Relay for Victor. He's asking, what's the question again? Are we talking about QNAME unification or RR type unification? Both or neither for SYMA and OpenPGP?
Only name.
And so the name shouldn't really be the whole registrar thing. But that was a fun little rat hole to go and explore. Anyone else?
Okay, so I thought we were only talking about the name, so I didn't talk about the RR type. So now let me talk about the RR type. We've already seen in the suggestions of how people want to do SMIME that it's completely different from OpenPGP key. So we should definitely keep a separate RR type. As for the lookup mechanism, which I guess is special label?
Yes.
Okay. So for the lookup location, clearly there's a benefit of doing it at the same location because both problems are identical.
So we need some more, or we would like some more reviewers for the SMIME document. Yeah, either now or when it gets updated. But we actually want to take names this time. Our brilliant thing of we're going to cancel this unless anybody comes along has generated a bunch of interest. A lot of people seemed as though they wanted to or were willing to actually work on it and review. Would you please put your hand up if you are willing to? Okay, for the scribe, that's poll voters.
Russ? Yes.
Yes. Is that Russ in the back?
Russ is in the back.
Russ.
DKG, Tim. We also have Ted Lemon and Hosnia in chat, and John Levine.
Okay. Does the
says
scribe
he'll review, but you know what I'll say.
Has the scribe managed to write some of those down? So, Russ Housley? Okay. We will be coming after you. Scary hat. And yes, please, we really do actually want to run to review. The document largely stalled because, everybody sounded interested until it became time to actually fess up with a review.
Are you expecting some revision of OpenPGP because of this knob discussion? And because then the SBIM document will need to track that, right?
I think that we do not have a clear consensus yet on what that last discussion actually resulted in, if anything.
I did not hear any consensus whatsoever, so I see no reason to change the current direction.
Yeah, there was no compelling argument to monkey with anything.
Yeah. So basically the document, SMIME and OpenPGP documents will go forward as they are right now.
No, that is, sorry, Paul Wouters, that is really confusing to me. First of all, I thought the agenda.
This is the same thing as Paul
Okay, so.
I thought the agenda today actually had a discussion item for this exact knob.
Yes.
So clearly we're still discussing it.
Yes.
So clearly it can't move on with the current draft. I mean, the latest proposals are not in the latest draft, so I don't think that's straightforward.
And further, the two drafts currently don't agree, and there was general agreement that whatever the first draft did, the second draft would do. So we aren't going with the current drafts at all. We're waiting for Paul to feel like he has what's, the consensus in the work group in his, and then Jakob and I will immediately go to that.
Okay. Local.
Yes. So I'm being a little impatient, but I didn't hear. I mean, I think it might be reasonable to ask the working group how would they feel about trying this since we're going experimental rather than waiting another cycle of trying to raise discussion again because we're all here to try to get a consensus call so Paul Wouters knows what to do with his draft. Oh, is it? Oh, I thought they were closing out this agenda item.
I thought that we'd got the feeling that that people were happy with Paul's thing because it was moving forward.
Yeah.
That we.
Okay, so okay, so so you're asking about the local part, Alison.
I was asking about the special label, so they're both in the same namespace, which I don't think we've finished, and so I don't think we have guidance on what happens with Paul Weller's draft and then the Paul Hoffman-Jakob draft. So it seems like calling consensus on your special label about whether to unify the Q namespace would be worth it, so that people can solve that and finish with this item, rather than waiting. I mean, maybe I'm too tired to get this right.
No, you're sort of right. So if I look on the agenda, it says that it has a specific slide that say where to store the SMIME and OpenPGP key records. And I guess that's not a motorcycle, but that wasn't clear to me.
That was the motorcycle. That was the Ducati.
Okay, so we can talk about the different proposals that are out there now, and then we can maybe happily all agree or not. So let me just rephrase it. And so the two current proposals that I'm aware of are the SHA-256 truncated version of the name versus the base 32 encoding of the split name. And I think there's also a version where we said if it's ASCII then lowercase, and if it's IDN then normalize and then hash. So there's sort of three options. And I have no real strong preference. My preference is for deciding. I think one looks a little uglier, but if people really want it, I'm fine with it.
I have a relay from AB in the chat room. Why in local part in SPIME cert and OpenPGP key are different? They will be the same. Okay.
Sorry, let me clarify. So of these three options, the base 32 split option is the only one that will support online signers and people being able to do fuzzy matching and other things, compared to the ones that do hashing where you only have one shot unless you do multiple queries.
I have a relay from John Levine. He says email is dominated by a handful of large providers with greater than 100 million users. Has anyone other than me talked to them about this?
And this is Paul Hoffman. No, he's the only one who's talked to him about it. So my preference, in fact, is to go with the base 32. It's not a strong preference. I'm definitely against trying to do the ASCII versus IDNA thing. I don't think we've thought about it well, and there's some EAI stuff there that could be really ugly. I mean, I think it can be done, but it would take a while to get it done well. I acknowledge John's concern about how things go, and I also believe that whatever we do isn't going to work well enough and that some other protocol is going to be needed. And given that, I think that the base 32 one is sufficient for now. If we completely blow this, we can fix it later. That will be bad, but it will not be a tragedy. Waiting forever and trying to do things for people whose size of audience we don't know is, I think, a worse thing to do.
Well, Paul, you might want to stay here. So two relays, one from John Levine. No normalization defined for UTF-8 local parts. And Paul just said correct behind me. And then the second one is Victor. It says online signing without fuzzy matching works with or without hashing. It's the fuzzy matching that requires base 32 and then forces online signing.
So these are all pretty much the arguments we've had on the list. That is, I'm not hearing anything new.
Hi, Peter van Dijk, Power DNS. The fuzzy matching requires base 32 because otherwise the DNS server cannot do dot stripping or plus sub addressing, etc. Once you hash, you lose this ability.
Does anyone strongly object to the base 32 idea? Okay, shall we hum for people who are okay with the base 32? Then we'll have another hum for people who dislike base 32, and another hum for people who believe that they have no idea what's going on. I might be in the third category, although... Oh, I thought he was going to the mic. Woohoo! So, first hum will be if you are... Clarification.
Sorry, no, since I just saw Steve walk to DKG, I was reminded of the fact that there might be privacy concerns with the base 32 version.
Sure. So DKG, the privacy concerns with the base 32 is just that anyone who's observing the query can see the exact email address that's being sent without having to do a dictionary attack against the hashing algorithm. So that's the right. If it was with the hashing, anyone who retrieves the query has to do a dictionary attack against the hash to figure out what email address was used. With base 32, you can just unpack it and find the email address. So the DNS query now leaks the email address directly, but against a powerful attacker with a simple email address scheme, it's likely that you could do a hash attack. So hash is slightly preferable for privacy, but it's not a total win.
Yeah. And just to emphasize, since we don't know how many addresses would be protected by the other one, we still would be guessing about how much privacy we were giving it on.
These feel like the same discussions we've had on this, exactly the same.
Sorry, the other privacy concern that we're generally thinking about with this stuff is whether you can just enumerate all the email addresses on a host by doing DNS queries. And I think they have the same properties in that case, because if you know what you're looking up, you can do either base 32 encoding or hashing. So the only concern is whether someone who's observing active DNS traffic, which hopefully would be protected by dprive at some point, but it isn't now, whether they can identify the email addresses directly.
So I think the three hums are going to be, I am okay with base 32. This is an acceptable thing to me. The next hum will be, I am not okay with base 32. This is horrendous. Don't do this. And the third option will be, we don't know enough to be able to make a useful decision. I believe that one means we'll never know enough to be able to make a useful decision. But Stan?
Sure. If we're going to do these, could you please just give me a minute between them when we are doing it for remotes?
Okay. First hum, if you are okay with base 32, please hum now.
Two hums remotely.
Okay, so for the record, there was... The remote people seem more enthused or more... So that was a sort of medium-ish kind of... Hum now if you believe that base 32 is a bad idea and we should not do it. Okay, much, much quieter.
Too remote.
Okay, and then hum now if you think that, hum now if you don't know or if you think that we really need to investigate this more before making some sort of decision.
Two hums remotely. Oops, I'm sorry, three. Lag time.
Any repeats online, Dan? Okay, we'll take this to the mailing list.
So as far as I can see from this, we have no consensus on what we should do. It seems that people like the base 32 more than dislike it, but an equal number of people think that we can't make a decision yet. I don't know how we get to a point where we can make a decision. We might need to, okay.
My impression of the last hum was that there were many people who were unclear on what the issue was or how to resolve it. Not that they thought that it was totally unsolvable. And it seemed like there was a much stronger hum saying, base 32 is probably okay than saying, my God, please do not do base 32.
In that case, let me please repeat the last hum. If you think that we should not make a decision now, that it would be bad for us to decide on base 32 or bad for us not to decide on base 32, basically bad for us to make a decision. This is not, you don't understand what's going on. I definitely fall in the last camp. If you think that we should not make a decision, please hum now.
Too remote. A different two, by the way.
We will propose this to the mailing list so we can, you know, actually try and hopefully figure this out. Please, 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 people.
Sorry, Paul. We've been doing this for 3 meetings now. Like, I seriously do not want it to take it back to the mailing list and wait another 3 months. Like, if you take it back to the mailing list, can we have a really short cut-off time so we can move on?
Yes. So
August 1st is going to be the decision deadline. Is that close enough?
Yes. August, and please, people, really, really, really participate in this actual discussion. I realize we did a really bad job here of the whole humming thing. I apologize for that, but we really need to actually get this as a clear question, get to a useful answer, and move on with this. Because, yeah, Paul has been doing this for a long time. We've been doing this for a long time. We're tired of it. Great. Any other business? We were way past our time, so it better be real important. Good. Blue sheets, has anyone not signed them?
Or have them?
Where are they? Who has the blue sheet? Thank you.
Yes. Okay. Sounded like you almost got it. Yes.